Okay, so here is lesson 5. You want to pause it really quick. This is our goal for today. We are going to be able to, after this lesson, we're going to calculate the mean absolute deviation. All right, and the way that that will be referenced in this lesson is the MAD. Okay, not to be confused with mixed numbers and stuff. That stands for mean absolute deviation. Okay, we're going to talk about the interquartile range, okay, and then mean and median. Okay, so a lot of vocab, and we're going to see how to calculate it and how to use our calculators to do that as well. Okay, so I'm going to go ahead and zoom in on this. If you need to pause the video and get that goal done, you can go back and do that. So 5.1, it says decide if each situation is true or false, explain your reasoning, okay? So the first one says the mean can be found by adding all the numbers in a data set and dividing by the numbers, by the number of numbers in the data set. So is that a true or a false statement? So think about it, maybe go ahead and write your answer down. That is actually a true statement. Okay, so that is what the mean is, which is very important as we move forward. So when you're doing that, when you're finding the mean, which is something you learned back in 6th grade, it's where if we had a data set 1, 2, and 3, if we wanted to find the mean of that, we would do 1 plus 2 plus 3, which is adding all the numbers, and then we would divide by how many we had. So then we would take all that and divide it by 1, 2, 3. We have 3 numbers, okay? So that would be 3 plus 2 is 5 plus 1, 6 divided by 3. So our mean would be 2, okay? Another word that they use for mean is the average, okay? So that's very important to know. That should all be a review to you. All right, so this one, again, it's a true or false statement. It says the mean of the data in the dot plot is 4. Okay, so we have to see if that is true. Well, if that is true, then we should be able to add up all of these values, divide it by how many we've got, and get 4. Now, just because y'all have a calculator, I'm going to show y'all how to do that on your calculator really quickly. Okay, so I'm going to move myself over here. So we go to Stat, Edit, we have our list. All right, I'm going to take all of the data values in this graph and I'm going to put it into my list. Okay, so how to read this. There's 1 dot above the 1, so I'm going to do 1 into my list, enter. There's 1 dot above my 2, so I'm going to do 2, enter. There's only 1, 1, and there's only 1, 2. Okay, now there's 2 dots above my 3, so I'll go 3, enter, 3, enter. There's 2 dots above my 4, so 4, enter, 4, enter. There's 1 dot above my 5, so 5, and there's 1 dot above my 6. Okay, so just the same exact process that you do the 5-number summary. You're going to go to Stat, over to Calculate, enter, and go all the way to Calculate. Okay, so from here, y'all learn to scroll down to the bottom and you see the min, Q1, median, Q3, and the max. Well, this very first number right here, the little X with the line above it, the little X with the line above it, that is your mean in calculator terms. Okay, so our mean of this data right here is 3.5. Okay, so is this a true statement up here? No, that would be false. Okay, so that's how you do it on your calculator. Same exact steps as to find the 5-number summary. Because look, if we just were to scroll down, we would get all of that information right there. All right, moving on to number 3. It says the median of the data set is 9 for the data. Is that true or false? Okay. Well, in order to answer that, we have to remember what the median is, which we talked about in lesson 2 or 4, one of the two. Okay, the median is the one in the middle spot. So they're saying 9 is the one in the middle spot. Is that true? It is if you look at it like this, but there's something that you have to remember when you're doing the median. You actually have to put the numbers in order, okay? So with a data set like this, it's not that bad. You can easily see which order they're supposed to be in. But when it's a lot larger data sets, which is typically what you'll be using when you're doing statistics, like if you had 50 to 100 or more data set, it would take forever to put it in order. So you could always put it in your calculator, but there's no need to because there's only 5. So you can see when we rearrange it, what is actually our median? 5. So that one is false. Okay, last one, the median of the data of the dot plot is 3.5, okay? So a lot of y'all may look at this dot plot and say, okay, well 3.5 is right there and there's no dots there, okay? But there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 pieces of data in this. So there's not going to actually be a number in the middle spot when there's an even amount. So this is one that, just to be safe, I would have typed into my calculator. So let me go up to the L1, clear it, hit enter, and I'm going to type in this data set. So I have 1 dot above my 1, so that's 1, enter. I have 2 above my 2, so that's 2, enter, 2, enter. I have 3 above my 3, so there's 3 3s. 2 4s, 1 5, 1 6, 1 7, and 1 8. Stat, calculate, oops. Okay, so it's asking me about my median, so I'm going to scroll down, and it says my median is 3.5. So is that a true statement? Yes, it is. Okay, so the important things to remember about this is that the mean is your average, and the median is the number in the middle spot. Okay, and just kind of, it was important that we went over those just to review, 1, what they are, and 2, how to find them, not only mathematically, but also with your calculators. My dog is scratching on the carpet, I don't understand. So yeah, so that is how you would do those. So now let's look at 5.2. Oh, and before we go on to 5.2, one thing that I also wanted to remind you of, when we're talking about the median, because that is our middle, aka the 50% point, okay, as we start interpreting data, that's saying that because we're splitting it right in half, right down the middle, it's saying that half of it is less than that amount and half of it is greater than that amount, which doesn't mean anything to us right now because there's no context. But as we start to look into real world context, that middle point is going to be really important to determine, okay, well, half of this is greater than 50 and half of it is less than 50% of it, or whatever. We'll look at some examples in a second. So go on to 5.2. Okay, so it says we're looking at heartbeats. So these are the heart rates of 8 high school students. Okay, so first thing is it gives us a vocabulary word. It says, what is the interquartile range? So that's a new vocabulary word for us. You have probably only seen it when we wrote it in your goal at the beginning of this lesson. So the way this is going to be referenced is the IQR. Okay, so in order to find the IQR, you actually have to take your Q3 and subtract your Q1. Okay, so we know a really quick and easy way to get those two values, right? we can just use our calculator. So we're going to take this data and we're going to plug it into our calculator. So hopefully at this point, after all the practice you've done with the calculator, plugging all this in takes no time at all. Okay, so I'm going to plug in these 8 students' heartbeats. So I have 72, 75, and it's really good that y'all are actually doing this in your calculators with me. So make sure you are, because that practice really helps. And again, because this is the only step you can mess up, you need to make sure you are taking your time and double checking all of these values. Okay, so I've plugged in all 8. Go to stat, calculate, enter. Okay, I'm going to scroll down. Okay, and right there in my calculator, it gives me those 2 values that I need. So the Q1 was 75, or I'm sorry, I'm doing it backwards. Q3 is 78.5, and we're going to subtract the Q1, which was 75.5. Okay, so this little formula right here is something you will need to know. Okay, so if we take those 2 values and we subtract them, that would equal 3. So my IQR is 3. So who cares what the heck does that even mean? Okay, well, if you think back to what a box plot looks like, so we have, this is a rough sketch. Okay, there's one for you. Okay, so here's my Q1, here's my Q3. It's telling me, the IQR is telling me this whole range of the size of the box of my box plot. That's what the IQR tells me. It tells you from where the box starts to where it finishes. And what you need to understand about that chunk of data is that whole box represents 50% of the data. Okay? So later on, that's going to be important to us, because when we're talking about that box, if that box is really long and there's like a lot of data represented in it, or the IQR is a very large number, that's going to mean that there are a lot of different numbers in that box that has a very wide range. And if that's the case, then that's going to tell us something specific about the data. Okay, whether it's and the fact that it changes a lot and it's not very consistent. But if that number is smaller, it has a smaller IQR, and the box itself is smaller, then it's not going to have much change. All the numbers are going to be really close together, and that's going to tell you something about the consistency of the data you're looking at, which will make more sense as we move forward. Okay, so that is what the IQR is. It is a measure of variability. Okay, it's a measure of variability. Okay, so it tells you how much the data is changing in your set. Okay, so remember that, make that little note. All right, moving on to number 2. It says how many values in the data set are less than our Q1. Okay, so our Q1 was 75.5. We got that already. Okay, I'm just going to go back and label it just so we know. This is our Q. I'm trying to do Q1. Third time. Here we go. Okay. Q1. That's my Q3. How many values in the data set are less than my Q1? Okay, so 75.5 was my Q1. So I have 2 values. Okay. Next, how many were between my Q1 and my median? So going back to my little calculator over here, you can see it. My Q1 was 75.5 and my median was 76.5. So let's see here. Let's change to 3. No. So many choices purple. Okay. So between 75.5 and 76.5. So I have 1, 2. So 2 again. Between my median and my Q3. So 76.5 and 78.5. So we got 1, 2. All right, well, we have 8 total. So what do y'all think? How many are greater than? There's 2. Okay, which we've kind of talked about this a little bit before in past lessons. What they're trying to get you to see in that question is that from our minimum is 0 to our Q1 is showing us 25% of the data right to there. Okay, and then we're seeing another 25% when we get to our median for a total of 50% from our minimum to our median. From our 0 to our Q1 is 25. From our Q1 to our median is another 25. Okay, from our median to our Q3 is another 25 for a total of 75. And then from our Q3 to our maximum is another 25%. Okay, for a total of 100% of our data. Okay, I'm going to erase that because that seems kind of confusing. Okay. All right, back to our question. Okay, so here's what I was talking about, applying it to a real world situation. All right, it says a pod of dolphins contains 800 total dolphins of various ages and lengths. Okay, so it's just a big set of dolphins, all ages. The median middle length of the dolphin in this pod is 5.8 feet. Okay, what information does this tell you about the length of the dolphins in this pod? Okay, so this question is really, really easy to overthink, but we just have to remember what it's asking. Okay, so the median, what does it tell us? It tells us the middle, which is half or 50%, if you want to think of it that way. So we have 800 dolphins. All right, what is half of 800 dolphins? Dolphin. Is there an S? Who knows? It would be 400. Okay, so if half of them, that's 400. I would have 400 on both sides, right? And they told me my median was what? Let me move myself over here. My median was 5.8. Okay, feet, I think. Yep. Okay, what does that tell me about the data? It tells me that half of the dolphins were less than 5.8 feet, and half of the dolphins were greater than 5.8 feet. Okay, and if you wanted to be more specific, you could say 400 of the dolphins were, because we know how much we had. Dolphins were less than 5.8 feet, and 400 of the dolphins were greater than 5.8 feet. Either one of those would work, but it's really easy to overthink that because of what it's asking, but we know that the median splits it in half. Okay, if we didn't know how many dolphins we would start with, all we could say was half of them were less than and half of them were more than 5.8. But since we know that there were 800, you can also be very specific and say that 400 of them were greater than or less than. Okay, Last question. Let me read through this real quick because I don't know if I want to do it or not. Okay, I'm just going to do it, but if it's super confusing to you, don't panic because I think this will kind of help explain that thing I was trying to show up here earlier. We'll see. Okay, let me zoom in to hide some of this stuff. Zoom in. Okay, here we go. Okay. So, new question, new scenario. We have the vocabulary test with 50 questions is given to 600 students from 5th to 10th grade, and the number of correct responses is collected for each student in the group. The IQR is 40 correct responses, okay? So that's out of the 50 questions, okay? So the IQR is 40 correct responses. What information does this tell you about the number of correct responses for students taking this test? Okay, now, I just want you to like sit and listen to this part right now, okay? You can draw it at the end, but just really listen to what I'm saying, okay? So, if my interquartile range is 40, and there are 50 total questions on this test, okay? So they could have gotten anywhere from 0 to 50 questions correct, okay? That's my minimum. That's my maximum, okay? My IQR, remember the IQR describes the box, okay? Well, my box is 40 of the total long, okay? So it's gonna be, start here, I don't know, and go all the way. It's gonna be a big box, okay? I don't know any of the other information, so I'm literally just guessing. Everything in red is a guess, okay? I don't know what those actual values are, okay? But what I do know is that the length of this box is 40, because that's my IQR, okay? Do you see how large the box is compared to our minimum and maximum, okay? So because of that, it says what information does this tell you about the correct responses? Because it's so large compared to my data set, okay, it takes the IQR, the box of it, takes up the majority of it, then it shows me that there's a lot of variability in the correct responses, okay? So we can't say either way that all the students did really good and got them all correct, or all of the students did really bad and got them all wrong, okay? Because there's so much variability, we can't say either way, okay? So that's basically what you would say. So because the IQR is so large compared to the total data set, the I don't know how to word it. Because the IQR is so large compared to the total data, the data has a large variability. That's what it tells you. Because the IQR is larger, then the variability is also large. Okay? So that's all it's really asking, if that makes sense. We'll keep practicing, don't worry. Okay, next part, 5.3. Okay, so I wanted to leave out this chart because I thought it was really confusing, and then I started playing around with how to do it in your calculator. And the calculator part is also a lot of steps, but once you see how to do it on paper, and then I show you how to do it on the calculator, you'll see you can determine for yourself which one you like to do better. Okay, so here's the last part of this lesson. And again, why they choose to make some lessons have like barely any information and then they pack really hard stuff into one, I don't understand, but here we are. So last lesson we talked about IQR, which was a measure of variability. And in this section, we're going to be calculating the MAD, which is the mean absolute deviation, which is also a measure of variability. Okay, it's a number used to determine how much the data varies. Okay, so as we move forward, you're going to see when you need to use the mean absolute deviation and when you should use the IQR. Okay, so you have to know how to calculate both so you know when to use what. So once again, we're looking at those same heartbeats using the same data from the previous activity by finding the average distance from each data value to the mean. Okay, you may find it helpful to organize your work by completing the table provided. Okay, so basically, this table is the steps that you take in order to find the mean absolute deviation. So, step number 1, you have to take the data here, that was 8 heartbeats, and we have to find the mean. Okay, so lucky for us, we already typed in all of the data into our calculator. Go to Stat, Calculate. We already had it up. Remember earlier, I told you this X with a line over it. Okay, that's the mean. Okay, so you can just take that number right there and plug it into your little table. So 76.25, and you're going to fill in this whole table. So I'm going to pause real quick. Okay, so fill in your whole table. All right, step 2. It tells you what to do. You're going to take the data value, and then you're going to subtract the mean. Okay? So, for example, let me get out of here. Oops. I'm going to do my data value, which is 72, and I'm going to subtract the mean, minus 76.25. Okay, so I got negative 4.25. Okay, and I'm going to do that all the way down my table. So I'm going to pause the video again, fill it in, and then you can check your answers. Okay, so that took way longer than it should have for me. Little technical difficulties. Okay, well, it's not the last step. They left one of the steps out, but it's okay. So now we're going to take the absolute value of those, okay? Absolute value means just make it positive. In the simplest way I know how to explain it, just make the number positive. Okay, so that becomes 4.25, 1.25, 4.75, 0.25, 0.25, 0.75, 2.75, and 1.75. So if it's already positive, it just stays positive. Obviously, you don't make it negative. Okay, so I know this is a lot of steps. Okay. So for some reason, it doesn't give the last step of it. So you can just kind of like add on another little box. Ooh. All right, we're going to take it and we're going to find the mean again of this column. Okay? We're going to find the mean once again. Now, you can do that by just taking all these and adding them together, and then dividing them by 8 because I have 8 numbers in my data set. Or if you don't want to risk it, which I never do, I'm going to go back to my list and I'm going to type them in. 4.25, 1.25, 4.75, 0.25, 0.25, 0.7, oops, no. Enter 0.75, 2.75, 1.75. Okay? That, calculate, edit. Okay. And so it says, I don't think I typed those in correctly. 4.25, 1.25, 4.75, 1.75, Oh, yep, there it is. See, right there. 1.75. Okay, there we go. So my after I find the mean of that, which AKA would be my mean absolute deviation, it would be 2, okay? Because that's that up there. So yes, I understand that is a lot of steps, but I'm gonna make a separate video showing you how to use your calculator for this so that you can reference it. I'm also going to make another little piece of paper for you to practice it. Okay, so there was a little box in here that said MAD, so we said it was 2. Okay, so, oh my gosh. So the mean absolute deviation. Okay, wow, that's a lot of steps to find a number. What the heck does that number even tell us? Okay, the mean absolute deviation, or the MAD, tells us how far our data varies or differs, you would rather use that word, from the mean or the average. Okay, so just like the IQR, if that IQR is really large, that means that the data changes a lot. Okay, it's very spread out. Okay, the same is true with the mean absolute deviation. If the mean absolute deviation is very large, that means the data is really far away from the average, which is the middle number. The average is the most common, really. It's not necessarily the middle. So if it's really far from the average, like just like in anything, if something's not like the everything else, then it differs a lot. Okay, and that's what the mean absolute deviation tells you. Okay, last question. You can do it. Believe in yourself. Okay, let's read it. See what it's asking us. For another data set, all the values are either 3 beats per minute above the mean or 3 beats per minute below the mean. Is that enough information to find the MAD? If so, find the MAD. If not, what other information is needed? Explain your reasoning. Okay, so basically what it's telling you is you have a number line. No, that's not what I want. You have the mean, okay? And then there's data showing you that some values differ as far as 3 above it and then 3 below it. Okay, so that is what the mean absolute deviation is. It tells you how far it is spread out from the mean. Okay, so is that enough information? Yes. Oh my gosh. I'm sorry, I'm having so many technical difficulties if I'm glitching out. All right, yes, it is enough information. The MAD is 3, okay? Because that's all the mean absolute deviation is. It's how far much the data is greater than the mean and less than the mean. And we'll practice more today. We just learned to calculate it. We're gonna learn how to interpret it more as we move forward. Okay, so we're done with lesson 3. Let's look at the lesson summary. Okay, it's very short. So we talked about the mean absolute deviation, or the MAD. We also talked about the interquartile range, or the IQR. Both of them are measures of variability. Measures of variability tell you how much the values in a data set tend to differ from one another. There's a lot of important information because this is so small. Okay, The greater the measure variability means the data is more spread out. Okay, so the greater the measure variability, the more spread out. The smaller the measure variability, the data is more consistent and close to the measure of center. Dang it. All right, and then it shows you a little thing on how to calculate the MAD. But you can always refer back to that table. Oh, wow. And then it also shows us how to calculate the IQR by subtracting the Q1 by the Q3. AKA, you could just do QR equals the Q3 minus the Q1. Now, it is important that the Q3 is first. So remember that. That is a little formula you will have to know as we move forward. Okay? So remember, to do that, you have to find the 5-number summary first in order to find your IQR. Okay, which is why I had you practice that over and over again, because that's just one little extra thing you can do with it. Okay, that's lesson 5. If you have any questions, please ask me. I know this isn't ideal, but this is a good review. So, yeah.